Okay, we are back. This is Techmath1. We're lecturing out of the blue book. We're looking at chapter 2. We're starting out here with 2.6, which is actually the first problem we're going to look at from 2.6 is on page 76 in the blue book. So we're looking at this problem. We're going to get all the variables over to one side. Now be careful. Don't let your brain trick you out of the right answer. This is why I want you to show your work. Even if you think these equations are easy and you don't have to show your work, I want you to show your work because this, your brain sees a -4 and a +4 and it says 0. And it says, oh, no solution, 0 equals 11. But that's not the case. If I add 4 to both sides to get all the variables over on the right side, I end up with 11 equals 8y, not 0, 8. And then divide by 8. And you can just leave it improper. 11/8 is equal to y. That's fine if you want to be fancy and write 1 3/8. You can write it as a mixed number, but if they don't indicate any kind of, they don't give you either context to the problem or indicate, hey, I want it as a mixed number, I want it as an improper, I want it as a decimal, then just leave it reduced. It does have to be reduced. Now look, 11/8 is reduced. It's just an improper fraction because the numerator is larger than the denominator. All right, let's look at this one. We would, let's get all the variables. There's no combining like terms already. That's unlike terms and unlike terms on both sides. So we can start in on solving this equation. I'm going to get all the variables to one side. So now we got 3x plus 9 equals 21. And then all of the numbers over to the other side. So 3x is, what is that equal to? 12. And then divide by 3. So x is equal to 4. Now, I think they had that one worked out already, and they said just check x equals 4. I did it, I checked it by re-solving it. If you wanted to, you could have subbed in 4 there and 4 there, and that would be 28 plus 9, and that would be 16 plus 21. Either way, you get 37, so 37 equals 37. So that would be the way to check it. So I just did a solution and found it, I think, the same way. Yeah, they had 4. So if you wanted to check it, you could have done it without solving it again to check it. You could have done it by putting in the 4 into where x was, and then seeing that that's 28 plus 9, which is 37, and that's 16 plus 21, which is also 37. So that would be the check. All right. Oh. Sorry. So let's take a look at that problem. Okay, so that's got fractions in it, and we don't want to work with fractions if we can help it. So let's multiply everything by the common denominator. The common denominator is 3. Let's multiply every term in the equation by 3, and then take a look at what that does. The 3's cancel there, the 3's cancel there. So now I've got this equation. 3x plus 1 equals 2x plus 3. Much easier to solve than with all those fractions. All right. Anytime you have an equation, an equal sign with, numbers on an equal sign where they're telling you to solve an equation, not just an expression, you can eliminate fractions by multiplying everything by the lowest common denominator. And then it makes it easier to work with. So this one actually works out to be pretty easy after we get rid of the fractions. So x is equal to 2. All right. Lovely, lovely. Let's look at 2.7, number 77. Again, they have an equal sign built in here because they want you to work it out going lengthwise instead of going downward widthwise. So let's look at 77 and let's look at 82. Okay, so they're not equations, they're expressions. We're just going to simplify them. So they basically want you to understand that when there is a negative sign in front of a parentheses, that's essentially like a -1 that you're distributing to both of those. So this is 2d plus -1 times 4d plus -1 times 7. And so if we work that, that's 2d minus 4d minus 7, and now you combine the d's together, -2d minus 7, all right? Let's do this one a little faster. Negative times both of those, so that's 7 minus p minus 1, and we can put the 7 and the -1 together, so it's -p and then plus 6. All right? And so I'm almost positive when I look at their answers, they're going to have it 6 minus p because they're all about that all the time. Yeah, they have -2d minus 7, and then they have 6 minus p instead of -p plus 6. They just hate writing that extra negative sign. All right, let's do these. Again, we are not solving equations here. We're just simplifying expressions. So we're going to take -4 times both of those, 20 minus 4d plus 8, and then combine up the like terms. So that's -4d plus 28. This is number 82. We got 10y minus 6y plus 27, and then combine up the like terms. So 4y plus 27. All right. Every time with that. They have 28 minus 4d. The only reason to write it the other way around like that, like in the book, if you check, this is fine if you wrote it this way. You write one less symbol. This is -4d plus 28. So look, they save writing the plus, but they switch it around the other way. I don't know, maybe they were getting paid by the typing symbol or something. All right, so either way is fine. Like I said, most of the time I will always left justify the variable. Okay, let's get to 8. Hopefully, again, this is review for most everybody watching this, if you're watching this. So 2.8, we're looking at 86. That's on page 82, number 86. F is equal to 11 minus 6f plus 7. All right. So some problems for us to work here. 8d8. We'll do 8p minus 2p minus 1 equals 0. And we'll do 92, which is 5 times t plus 3 equals 3 times t minus 5. All right. Cool beans. Let's take a look. So we have to do, this is solving equations. There's an equal sign, and numbers on both sides. So here we go. F is equal to 11. Do the distributive property, minus 6f minus 7. Combine like terms. So put that and that together, negative 6f. What is that? 3, 4 plus 4. And now we want to get all of the variables over to the left side. So we will. So right now we didn't do anything. We just cleaned it up. We distributed the negative. We combined the like terms. And now we're going to solve, all right, for f. So we add 6f to both sides. So I busted out the blue marker here. This is the first step of the equation. And then divide by 7. So that is our answer. F is equal to 4/7. All right. Where is that? That's back. Uh-oh. Which one? 86. 86. That's a good year to graduate. Okay. Let's look at this. Same dog, different fleas. 8p minus 2p plus 1. Remember, it's negative 1 times that. That's the negative. And negative 1 times that. Don't forget that second one, distributive, because of the parentheses. That's a very, very common error I've seen over my career. All right, so now let's combine like terms. And now, again, we're ready to solve. So subtract 1 and divide by 6. So p is equal to negative 1/6. Do the distributive property, 5t plus 15. Do the distributive property, 3t minus 15. And so now there's no like terms to combine like there was on this. So we can just do the distributive property and then get right into solving this equation. We'll get all the variables over to one side. When you zap that variable, be careful to remember that negative is on the 15. That's, again, a very common error. So t is equal to negative 15. And again, you can check every one of these problems by subbing it back into the original. All right. I want to do one more problem on 2.8. That one is number 95. Number 95. Which is, it's on page 84, and we're looking at 20 is equal to t minus 3 times quantity 5 minus 2t. So first things first, do the distributive property. So we have 20 is equal to t minus 15 plus 6t. Combine like terms, so we're going to clean up the right side here a little bit. So 20 is equal to 7t minus 15. Add 15 to both sides. So 35 is equal to 7t, and then divide by 7. So 5 is equal to t. And again, when I say you can sub in and check, you can pop that 5 right there and right there. So look, 5 minus 10, because 2 times 5 is 10. So 5 minus 10 is negative 5. Negative 5 times negative 3 is positive 15. And then 5 plus 15 is 20. So you can always check it back. All right, here we're going to do the last section really quick. 2.9er. and that's square roots. So when you think about math, there's always an opposite to everything. So the opposite of squaring a number is to take the number's square root. So a square root is just asking, it literally comes from geometry. If I had a square and the area of the square was 81 square feet, what would the square's root be? Meaning 9 times 9 is 81. So the square's root is 9. The square root of 81 is 9. That's where it came from. So let's take a look at page 85 in the blue book, 2.9, number 97. They got the square root of 1, the opposite of the square root of 64. The opposite of the square root of 4, let's look at 98. They got plus or minus the square root of 4. They got plus or minus the square root of 1. And they've got plus or minus the square root of 81. So the square root is asking what times itself gives you that number. So that would be 1. It would be, the square root of 64 is 8, but it says the opposite of the square root of 64. So we throw a negative on it. 2, we throw a negative on it. Plus or minus, so we just keep that plus or minus there. So now let me give you some context with this plus or minus. Why would we see plus or minus? It was born from geometry, so when you take the square root of a number, you just give me the positive value. That's called its principal root, because distances have to be positive. But in algebra, sometimes we'll see things that look like this. X squared is equal to 81, which means algebraically there are 2 solutions. So when we take the square root of both sides, we toss this symbol in front of it, plus or minus, and there are your 2 answers. X is equal to 9, X is equal to negative 9. And so that's where that plus or minus symbol comes. It's just shorthand for, instead of writing out the answer 2 times, that's for algebra. You might not see a lot of plus or minuses in this course because it's usually applied mathematics in here. And so it's usually we're not worried about the abstract. We're worried about the concrete, the real answer. So we're usually sticking with the positive answers anyway. All right, let's look at 104. So that is the square root of negative 81, which we eventually will answer, but not now. The opposite of the square root of 81 and the square root of 1/4. Okay, so let's do the easy ones first. This is like taking the square root of 1 and the square root of 4 separately. That's 1/2. So that one's easy. This one is just, we did it already actually there. It was just the opposite of 9. This one is no real solution. We will eventually talk about the imaginary numbers, the complex number set. But not right now. So think about that. You cannot tell me a number times itself, a real number times itself, that'll give you negative 81. Because if you say, well, no, negative 9. No. Negative 9 times negative 9 is positive 81. And you can't say one of each. It's got to be the same number times itself. So that's why you can't take the square root of a negative number.